Alright, welcome to 8.2 Notes, Solving Exponential Functions and Inequalities. We are going to start off with a statement. B to the x is equal to b to the y if and only if x is equal to y, where b is greater than 0 and b cannot equal 1. And as a note, the b's here, these are the same base. Alright, so let's take a look. We're going to jump into an example. So we'll call this example 1. And example 1 says to solve So we are given 4 to the 8th power is equal to 4 to the power of 2x minus 2. And what we want to do is we want to use our statement to help us solve this. So the statement says b to the x is equal to b to the y if and only if the exponents are equal. So are the bases the same on this problem? Are the bases of the left and the right the same? Give me a head nod, yes or no. Yeah, show me on your hand what are the bases. Good, so the base is 4. They are the same, so if the bases are the same, what that statement says is that we can take the exponents and set them equal to each other and solve. So if the bases match, we can take the exponents, set them equal to each other, and solve. So once we do that, it should be easy solving. So if the bases are the same, we're going to take the exponents, set them equal to each other, and solve. Okay, example B. We are given 2 to the power of x is equal to 8 to the 3rd. Are the bases the same? Give me a head nod, yes or no. Are the bases the same? No, they're not. I have a base 2 and a base 8. Let's think about this. Can we rewrite 8? Can we manipulate 8 and to be written in terms of 2? So let's think. 8 is 2 to the what power? How many times do I multiply 2 together to get 8? 3. So 8 is 2 cubed. Well, let's substitute that into our problem. So 2 to the x is equal to, and then instead of writing 8, I'm going to write 2 cubed. So I'm just making a substitution. Then I have a power to a power. So what do I do with the 3's? Do I add, subtract, multiply, or divide them? What do I do with the 3's? We're going to multiply them. Good. So I have 2 to the x, which is equal to 2 to the 9th. So a power to a power, 3 times 3. We're going to multiply them. Now are the bases the same? Give me a head nod. Yep. 2 and 2. So I can just say the exponents must be equal. X must equal 9. Okay, let's do another one. Call this example C. In example C, we're given 9 to the power of 2x minus 1 is equal to 3 to the power of 6x. Okay, give me a head nod. Are the bases the same? No, we've got a 9 and we've got a 3. However, let's think about this. Can I rewrite 9 in terms of 3? I know that 9 is 3 to the what power? Show me on your hand. 3 to the what power? Second. Very good. So we're going to substitute that in. So instead of writing 9, I'm going to go ahead and write 3 squared. On the left, I've got a power to a power, which we just said we need to multiply. And when I multiply, what do I need to make sure to do? What's that thing called with the lines? What's that called? Distribute. We need to make sure to distribute. So this is 3 to the power of 4x minus 2 is equal to 3 to the power of 6x. Now are my bases the same? Yep, so if my bases are the same, I can take the exponents and set them equal to each other, and it should be easy solving from there. So I got 4x minus 2 is equal to 6x, and then this is just two-step equation, right? So this should be easy solving. Go ahead and solve this one. So we should get x equals -1. Okay, let's do another one. We'll call this example D. In example D, we have 5 to the power of 5x is equal to 125 to the power of x plus 2. Are the bases the same? Give me a head nod, yes or no. Are the bases the same? No, but could I rewrite 125 in terms of 5? It's 5 to the, well, if I'm not sure, I could grab a calculator and I could just start multiplying 5. So I know 5 times 5 is 25, times 5 is 125, so that was 3 5s. So I know that 125 is 5 cubed. And I'm going to go plug that in. So I have 5 to the power of 5x is equal to 5 cubed to the power of x plus 2. On the right side, what do I need to make sure that I do with the 3 and the x plus 2? What's that called? The thing with the lines? It's called what? Distribute. Good. So we need to make sure that we distribute here. So this is, it becomes 5 to the power of 3x plus 6. Now give me a head nod. Are the bases the same? Yep, so if their bases are the same, we're going to set the exponents equal to each other. And it should be easy solving from there. Two-step equation. So go ahead and solve it. So when you solve it, you should come up with 3. So these are exponential equations. Now we're going to do 3 problems where we're looking at exponential inequalities. So the only difference is that we have an inequality, but we're going to use the same process. So I'm going to zoom out, and I'm going to go all the way back over to the left side of the page for example E. In example E, I'm given 16 to the power of 2x minus 3 is less than 8. Okay, give me a head nod. Do we have the same base? No. Could we rewrite 8 in terms of 16? Can't we write it as 8 squared? No. So that's a really common mistake. Sometimes we think 8 squared is 16 because the 8 times 2. But 8 squared is actually 64 because we're multiplying 8 times 8. So let's think about this. Is there a number that 16 and 8 could both break into? If you can think of that number, show me on your hand. What number could 8 and 16 both break into? So some of us are saying 4. 8, so let's think about this. 8 is 4 to the what power? Ooh, so 4 is not going to be it. So what's the number going to be? What will they both break into? Good. So a lot of us are saying 2. So I know that 16 is, let me think in my head. Okay, 2 times 2 is 4, times 2 is 8, times 2 is 16. So that was 4 2's. And then 8 is 2 cubed. So it won't always be the case that one will break into the other base. Sometimes we might have to come up with a number that they can both break into, so they both can break into 2's. So let's substitute that in. 2 to the 4th. And 2 to the 3rd. On the left, I need to make sure that I distribute. So this is what? 2 to the 8x minus 12, which is less than 2 cubed. Are the bases the same now? Yep. So we can set our exponents. Bring them down. 8x minus 12 must be less than 3. And this should be easy solving. Remember, just because we get a fraction doesn't mean that it's wrong. Just because we get a fraction doesn't mean it's wrong, and it doesn't mean that we messed up. Okay, it's normal that we're going to get fraction answers. So we should have gotten x is less than 15 over 8. All right, let's take a look at another one. We're going to do 2 more, and then we're going to end with a word problem. So we'll call this example F. In example F, we are given 2 to the power of x plus 2 is greater than 1 over 32. Okay, so we have a new little obstacle in our way. That fraction, 1 over 32. So let's think about this. Let's just think about 32 without the fraction. Can 32 break into 2's? Yeah, 32 can break into 2's. How many 2's does it break into? How many? Not 4. 5, good. So 32 is 2 to the 5th. What kind of exponent would make it flip into a fraction? What kind of exponent makes things flip into fractions? Negative. So I know that 1 over 32 is 2 to the negative 5th. Does everybody see how I came up with that? So 2 to the 5th is 32. And to make it flip and put it under 1, we have to make it a negative 5. So now I'm going to go substitute this in. 2 to the power of x plus 2 is greater than 2 to the negative 5th. Now the bases are the same, so I can drop down the exponents, and it should be easy solving from there. So we've got x is greater than negative 7. Okay, let's practice another fraction problem. So we'll call this A, B, C, D, E, F, G. Example G. We are given 1 over 625 is less than 5 to the power of 3 minus 2x. Alright, so are the bases the same? No, but can I rewrite 625 in terms of 5? Let's think about that. 625 in terms of 5. So I could grab a calculator and I could do, okay, 5 times 5 is 25. Times 5 is 125. Times 5 again is 625. So that was 4 5s getting multiplied together. So I know that 625 is 5 to the 4th. And what kind of exponent makes it flip into a fraction? A negative. So this is going to be 5 to the negative 4th. So when I plug that in, 5 to the negative 4th is less than 5 to the 3 minus 2x. Now my bases are the same. So I'm just going to drop down the exponents. And it should be easy solving from there. Now when I wrote that wrong. That should be 4. So when I'm here and I divide by negative 2, what alarm bell should be going off in my head? If I divide by negative, flip the sign. Good. So when we use inequalities, you gotta remember sometimes we need to flip the sign. Alright, so we're going to leave off with a word problem. And our word problem, this is going to be something you might see in a science class. We're going to talk about the growth of bacteria. So we'll call this example 2. This might be somewhere where it might be faster to type it. Depending on if you're a fast typer or if you're faster at writing. So we started with 7,500 bacteria cells. After 4 hours, we have 23,000 cells. And we are going to, in part A, write an equation. This is the equation we're going to use. Y is equal to A times B to the X. Where Y is our final amount. A is the initial, kind of like the equation we used in the last set of notes. B is the rate, and X is going to be time.